So in this lecture, I'd like to give a brief introduction to alkanes. Now, alkanes are a member of a family of hydrocarbons, and that simply means alkanes are composed entirely of carbons and H atoms. Now, all linear alkanes have the following molecular formula: C subscript N, H subscript 2N plus 2, where N designates the number of carbons. For example, if N is 10, if we have an alkane composed of 10 carbon atoms, that means we're going to have 22 H atoms. 2 times 10 plus 2 is 22. The simplest alkane is methane. Methane is composed of 1 carbon and 4 hydrogens. Now, the molecular formula is CH4. This can be represented another way using the following diagram. So the carbon, the central atom, is attached to 4 identical H atoms in the following manner, where each bond is a covalent bond, and each bond is sp3 hybridized. Now, what happens, for example, if we take away this H atom, and along with the H atom, we take away 1 electron, and we leave 1 electron on this molecule? Now, let's suppose I take 2 of such molecules and I interact them in such a way so that I form the following compound. So, these 2 electrons interact to form a covalent sp3 hybridized bond, and I form a compound with 2 carbons. So now I have ethane, which has the molecular formula C2H6. Now I can continue doing this to produce propane, butane, pentane, hexane, heptane, octane, and so on. Now, butane, for example, is another type of alkane that's composed of 4 carbon atoms. So I essentially took 4 of these molecules, I combined them, and I got the following butane molecule. Now, another type of alkane are cycloalkanes. These are simply cyclic versions of our alkanes. And here I have 2 examples. For example, cyclopropane and cyclohexane. So essentially, propane, pro means 3. Ane refers to the alkane, and cycle means it's in a cyclic fashion. So here I have cyclopropane and cyclohexane, 6 carbon atoms and 3 carbon atoms here. Now, the formula for cycloalkanes is not the same as the formula for linear alkanes. The formula for cycloalkanes are CnH2n. And we can see that this, in fact, is true. Here we have 6 H atoms, and we have 3 carbon atoms. So 3 carbon atoms, and that means we'll have 2 times 3, 6 H atoms. Likewise, here we have 6 carbons. That means we will have 12 H atoms. That's exactly what we have. 2, 4, 6, 8, 10, 12. So once again, alkanes and cycloalkanes are essentially entirely composed of H atoms and carbon atoms. The only difference between alkanes and cycloalkanes is the fact that in the molecular formula, we're going to have 2N plus 2 for alkanes and 2N for cycloalkanes.